Today we're going to be working on solving log and exponential equations. Now recall that logarithms and inverses and exponents are inverses of each other, just like addition and subtraction. And it kind of tells it here, if you're to add, you would subtract. The same is true for logarithms. To solve a logarithm, we use an inverse, which is exponents, and vice versa. So to solve an exponent, we would use a logarithm. So we're going to be using the inverse property quite a bit today. And remember, the inverse property says the log base b of x equals y if and only if b to the y equals x. And we use this to solve. Now, so we're going to be using a lot of our little properties here today, so we got to make sure we work on these. All right. So for the first one, well, for this one, we actually don't have to use a logarithm to solve. We can use just the same base. So this is just like a kind of an old review for us. So if I want to try this one, it's going to be 3 to the x equals, and I don't know, 3 to the what equals 243. That's just 3 to the 5th. So this is just an old one. Maybe remember, if you can write it as the same base, you don't have to use logarithms. So here we get x, of course, equals 5. For number 2, now we're going to solve this one, but before we can do it, we must condense first. And that becomes the natural log of x times 5 equals 2. And then to solve this, now I'm going to use my inverse. I'm going to rewrite this because I don't like the way that looks. I like 5x. This looks more natural to me. So to solve this one, a natural log, I must use my inverse property. In other words, exponents. So remember, natural log is base e. So I take my e, raise it to the second power, and that's going to equal 5x. So therefore, what's x going to equal? E squared over 5. Very easy to do these. All right. Let's take a look at number 3. Now number 3 is kind of like number 1. It is exponential, but the difference is we don't know how to write e4 in terms of base e. So to solve this one, now we're going to use our natural log rules. We're going to use natural log. Now, the inverse of e is a natural log. So what we do is we just take the natural log of both sides. Because if I take the natural log of e to the x, I'm going to take the natural log of 4. And the reason we do this is because the natural log and e are inverses of each other. Those cancel out. And we're just left with x equal to the natural log of 4. And there is our answer. Alright. Let's try number 4. Same way. It's very similar to like number 2. It's already been simplified. Remember, this is the natural log of x equals negative 7. Now before we begin, one thing I kind of want to mention, natural logs always have a domain restriction. Whatever here has to be greater than 0. So we always should check those. Alright, so if I want to solve this right here, so if your x is in the answer or the inside the natural log, you should always check a domain restriction. So now I'm going to solve it. This becomes e to the negative 7 equal to x. I'm just using my inverse property. So x equals 1 over e to the 7. It's tiny, but still greater than 0. And there's our answer. So let's try this one. Again, I have an x here inside my log, so I do have a domain restriction. X has to be greater than 0. So let's try solving it. Not natural log this time, we're base 5, so we're going to go 5 to the negative 3 equals x. So what's x going to equal? 1 over 125. Still positive. We're good. So let's take a look at number 6. Now 6 is kind of an interesting one here. There's 2 ways we can solve this one. I'm going to show you the easiest way here. But first we do have a couple domain restrictions. Let's check them both out. This one says x has to be greater than negative 5/2. This one says x has to be greater than 0. Now, since 0 is bigger than 5/2, we don't worry about that one. So our domain restriction just says x has to be greater than 0 here. Alright, now, how do we solve this one? I'm going to use my inverse property again. I take my 4 and raise it to the side. So I get 4 to the log base 4 of x equals this 2x plus 5. And what we've been talking about, because the exponent and the log have the same base, those cancel. And I get x equals 2x plus 5. On example number 9, I will show you a shortcut for this one. Bring the 2x over, we get negative x equal to 5. And look what happens here when I solve it. I get x equals negative 5. But my domain restriction said it had to be greater than 0. That doesn't work, so we actually get no solution for this one. Therefore, no solution. Kind of a good one right there. Alright, let's take a look at number 7. Again, I have a domain restriction. I'm saying x squared has to be greater than 0. That's just basically saying x is greater than 0 or x is less than 0. That's what this domain restriction means for us. Because when you take the square root, remember, you get a positive and you also get the negative. But when you get the negative, you have to switch your direction. So I'm going to solve this. E to the 20th equal to x squared. So I got to take the square root. Remember, when you take the square root, you get two answers, plus or minus. Now, I can leave it as e to the 20th, the square root of that. Or that's just plus or minus e to the 10. Now, both work because my domain restriction says it can be either bigger than 0 or less than 0 in this case. And the reason that works is because I'm squaring it. This number in here is always going to be positive, so that's why the negative will work here. All right. For problem number 8, if I'm going too fast, pause it if you need to. Just catch up with us, that's fine, not a problem. All right. The first thing we do for number 8, because we're subtracting, we're going to write this as a division. Log base 2 of x minus 3 over x plus 2 equals 3. Now, I haven't done my domain restrictions yet, so let's go ahead and do those. This one says x has to be greater than 3. This one says x has to be greater than negative 2. Now, because 3 is bigger than negative 2, we don't count that one. So it just has to be greater than 3. Right. So, solving it, we're going to use our power rule, our inverse. So we get 2 cubed equal to x minus 3 over x plus 2. And be careful, that's just 8, so I'm about to knock some of you guys out of the ballpark here. This becomes 8x plus 16. Well, what did I do? Cross multiplied equal to x minus 3. Solving it, we get 7x equals negative 19, so x is negative 19 over 7. And there's our answer. All right. Let's take a look at number 9 here. Now, number 9, like I promised, I am going to show you a shortcut from number 6. Of course, I'm going to simplify this. Write this as write this as multiplication, because I got to subtract the addition here. So I can write this as the log base 8 of x minus 3 times x equals the log base 8 of 4. Now, what you may recall from number 6 up here, take a look what happened to this. When I use my inverse property, the 4 and the log base 4 canceled, leaving me with the x. So because of the inverse property, the way it works, after you simplify and you have logs on both sides that have the same basis, they kind of just cancel each other out. You don't have to worry about those. Now, the one thing I haven't done yet, mess with my domain restrictions. So this one says x has to be greater than 3. This one says x has to be greater than 0. But again, because 3 is already bigger than 0, we don't worry about that one. So we just say greater than 3. And then I'm going to solve it. Distribute. X squared minus 3x equals 4. And this is going to give me x squared minus 3x minus 4 must get it equal to 0 and factor like an actor. We're going to get 4 and 3, 4 and 1, that's awful, negative, positive. So we get x equals negative 1, x equals 4. Negative 1 is outside of my domain restriction, so our answer is 4. Now, we had a name for this one. Remember from Algebra 1, we call this extraneous. It's an extraneous solution. You actually get an answer, but it just doesn't work for us. All right. So, let's take a look at a couple calculator questions here, okay? So, you'll need a calculator for the next few. All right, we'll take a look at a few here. And again, if I'm going too fast, feel free to slow it down, pause it if you need to, okay? All right, For the calculator to solve it, we're going to round to 3 decimal places. Now, just because it says use a calculator doesn't mean you don't do your work. You got to show your work still. I'm going to divide both sides by 2. We're going to get 5 to the x equals 16. Now, this is why we have logs. Why we have logs. We can't solve this. Now, I know 5 to the first is 5, and I know 5 squared is 25. So I know x has to be between 1 and 2. But I can't solve this by hand because I don't know what power I need to raise 5 to get 16. But that's what John Napier came up with, logarithms. What he said to do is, well, since I can't write 16 in terms of base of 5, I'm going to take the log. Now, for the most part, we always use the natural log. Take the natural log of both sides. I get the natural log of 16. And the reason we like logs, because we can bring the power down. X natural log of 5 equals the natural log of 16. Now, back in my day, we had to look up tables to get this answer. But luckily, we have calculators. Of course, I divided by the natural log of 5 on both sides. And then I'm going to type this in my calculator. I just type in the natural log of 16, whoops, not 169, divide that by then, just 1, divide that by the natural log of 5. I hit enter, and here's my answer, 1.723. That's 3 decimal places, 1.723. And there's our answer right there. Very easy to do, okay? But so let's take a look. Let's see how close this is. 5 to the 723. I get 16.075. Of course, it's going to be a little bit over because we rounded up, but it's pretty accurate. All right, so in part 2, we're going to take a look at a bunch more of these, okay? So make sure you go to part 2, and if you need to, go back and try part 1 again, okay? Thank you.